Hey there, today we're going to expand our knowledge on graphing linear lines, which we know are nice straight lines, except this time we're going to add in a little bit something different. We're going to graph linear inequalities. So we're going to add into our inequalities our less than or greater than or equal to symbols or the less than or greater than symbols. So if we have the greater than or equal to or the less than or equal to symbol, our boundary line is going to be solid. And a good way to remember that our boundary line is going to be solid is if we see the little line underneath the inequality, that's how you know you're going to have a solid line. If we have the less than or greater than symbol, our boundary line is going to be dashed. All right, let's hop into our first example. Our first example is to graph negative 4x plus y is greater than negative 3. And we're going to go ahead and get y by itself here, just as we did with y equals mx plus b. So we can use slope and y-intercept to graph this. So to do that, we're going to need to add 4x to both sides. By adding 4x to both sides, we end up with y greater than 4x minus 3. So now we know that our slope is 4 and our y-intercept is negative 3. So I'm going to start by plotting my y-intercept at 0, negative 3, and using my slope of up 4 over 1, up 4 over 1, I'm going to plot a couple more points. And now we need our boundary line. Because we are having a greater than symbol, our line is going to be dashed when I hook our points together. Now the final piece is that we need to shade a certain area because there's more than just the line that's at stake here. So we want y values that are greater than because we have the greater than symbol. So y is getting bigger going up, right? Because this is 0 and all of these numbers are getting bigger. So going up, we are getting greater, which means I want to shade here on the left-hand side here because this is where my y values are getting greater than. So I would shade this area on my graph. Let's try another one. Let's try x plus 2y is less than 4. Again, we want to get y by itself, so we first need to subtract x from both sides. That will leave us with 2y is less than negative x plus 4. But y isn't quite by itself yet. We need to divide everything by 2. So when we divide everything by 2, we're going to end up with y less than negative half x plus 2. We know that our slope is negative half and our y-intercept is positive 2. So I'm going to start by plotting my y-intercept at 0, positive 2, and use my slope down 1 to the right 2 to post my next point. And let's just put one more. Again, we have the less than symbol, so we're going to end up with a dashed line to connect these points together. And now we need to shade. So looking at our symbol, I want y values that are less than. So we want y values that are getting smaller. So we get smaller going this direction on the y-axis. So I'm going to shade underneath my line here. So underneath here is going to be shaded. Example 3, here we have 6x plus 3y is greater than or equal to negative 9. Same thing as the previous two examples, we need to get y by itself. So to do that, we're first going to have to subtract 6x, giving us 3y is greater than negative 6x minus 9. Y isn't quite by itself yet. We need to divide everything by 3. So when we divide everything by 3, we're left with y is greater than or equal to negative 2x minus 3. Here our slope is negative 2 over 1, and our y-intercept is at 0, negative 3. So we'll start by plotting our y-intercept at 0, negative 3, and then using our slope, we will go down 2 to the right 1, and down 2 to the right 1. This time, though, we have a greater than or equal to symbol, so our boundary line is going to be a solid line. And now we need to shade. Here, looking at our symbol, we want y values that are greater than. Again, y gets greater going this direction, so we'll want to shade on top of our line. And our last example, we have 2 times negative 3x minus y is less than or equal to negative 8. We need to get rid of those parentheses, so let's distribute 2 through, giving us negative 6x minus 2y is less than or equal to negative 8. Let's go ahead and get y by itself, so we need to add 6x to both sides, leaving us then with negative 2y is less than or equal to 6x minus 8. To get y by itself, we need to divide everything by negative 2. And be careful. This is super important because if you recall our division or multiplication of a negative number with inequalities, that flips our sign. So make notes somewhere on your notes in front of you that anytime we divide or multiply by a negative number, our sign is going to flip. So notice we went from a less than or equal to a greater than or equal to. So y is now greater than or equal to negative 3x plus 4, since a negative divided by a negative is a positive. Our slope is negative 3 over 1, and our y-intercept is at 0, 4. So we'll start by plotting our y-intercept of 0, 4, going down 3 to the right 1, down 3 to the right 1. Now that I've got my points plotted, I can see that it's because it's a greater than or equal to symbol, we're going to have a solid line which connects our points. One step further, we need to shade. So notice that we want y values that are greater than. So y is greater going up. So we want to shade here above our line. And that wraps up our graphing linear inequalities.